Okay, so we're going to spend 2 days on section 2.3, and we're going to focus on finding real zeros. So we haven't looked at the imaginaries yet. We've already done a lot of things to find real zeros, but mostly it's been factoring or graphing on your calculator to get the zeros. But what if you can't factor something? So look at example 1. Is that something that's easy to factor? No, the best you could do would be factor by grouping, and then you still may or may not be able to get the correct answer. So we're going to review polynomial long division and synthetic division today. My favorite things. Yay. So we're going to divide this polynomial by x minus 2. So the bad thing about polynomial long division is you do have to know one of the factors in order to do it. The other thing is you have to make sure that you're not missing any x terms. Little fuzzy, still fuzzier. That's the best we're going to get. One more. There we go. Okay, so I'm going to divide that. Am I missing any x terms? I've got x cubed, x squared, x, and then my constant. If I am missing x terms, I have to put in a placeholder of 0, x to the whatever. So this I don't have to worry about. So take your 6x cubed minus 19x squared plus 16x minus 4, and divide all of that by exactly x minus 2. So this works exactly as long division does. You're going to always focus on the first terms. So I'm going to focus on the x and the 6x cubed. What do I need to multiply x by to get 6x cubed? Or just divide these two. What's 6x cubed divided by x? So a 6x squared goes up top. Then I have to take that 6x squared and multiply it to everything outside here. And when you multiply 6x squared to the x, you should get exactly what you started with, which we do, 6x cubed. And then 6x squared times negative 2x, or negative 2, negative 12x squared. Then you're going to draw your line and change all your signs because we are subtracting. So I want to add the opposite. So I'm going to draw my line, change my signs to all their opposites. So I went a negative and a positive. 100% of the time, your first term should cancel out, and they do. If they don't, you did something wrong. Then add down what's negative 19 and positive 12. What does that give you? Negative 7x squared. And if these are not like terms, you've also done something wrong. You've either missed a placeholder, or you multiplied wrong, or this is wrong up here. So then the whole process starts all over again. Well, after, don't I have to move a term down? So I'm going to move down my 16x. Now the whole process starts all over again. So again, I want to focus on the first two terms. So my focus is now on these two. Take negative 7x squared and divide it by x. What do you get? Negative 7x. Then multiply everything outside by the negative 7x. So negative 7x times x. Negative 7x squared. Negative 7x times negative 2. Positive 14x. Draw your line. Change all your signs. So now my first terms cancel out. What's a 16 and a negative 14? So positive 2x, bring down the last term. So minus 4. Starts all over again. So you're going to focus on the 2x along with the x. Divide those two out. What's 2x divided by x? Question. This 14 is negative, right? So I did. Oh, you mean originally? Because I have a negative times a positive. So negative times a positive. I'm sorry, a negative times a negative is a positive. Does that make sense? Okay. So are we all good? Okay. So then what's 2x divided by x? 2. So I have a plus 2. And then I multiply this through. So 2 times x, 2x, 2 times negative 2, negative 4. Then don't fall apart at the end. Make sure you draw your line and change your signs. And in this case, everything cancels out, and I have a 0 as a remainder, right? I'm gonna sneeze. Maybe. Okay. It didn't happen. So this would be my remainder, which I don't have one. But if there was one there, we'll deal with that in a minute when we get one. But there's my remainder. I have no remainder. So what that means is that x minus 2 is definitely a factor of that polynomial. If you have no remainder, this is a factor. So they want us to divide, which is spelled wrong. Mr. Gleason. That is so funny, right there. The i's in the wrong spot. And then use the result to factor the function f completely. So since I have no remainder, I know that that x minus 2 is a factor. In normal long division, if I took this times this, shouldn't it give me what's underneath? So technically, so this is step 1. Technically then step 2, I'm going to take my x minus 2 that I divided into it, and I'm going to multiply it to my result, 6x squared minus 7x plus 2. Now I have a quadratic. Can I factor that quadratic? So remember that I've given you a different factor method. So you're going to take this 6 and this 2, and you're going to do 6 times 2, which is a positive 12. Because the 12 is positive, we're going to add the factors of 12, and we were looking for a middle term of negative 7. What factors of 12 add to give you negative 7? So 3 and 4 give us 7. We do want our 7 to be negative. We have to pay attention to our signs. So you're right that both of them are negative. So then we're going to use our box. You're going to put your bookends, which is your 6x squared, and your positive 2 on this diagonal. Then these two middle terms, you're going to attach a variable to them. My variable is x, so this becomes a negative 3x and a negative 4x. They go on the other diagonal, doesn't matter what order. But remember, these are the boxes that determine the sign. Oh, that's this class, and I haven't taught you this yet. Oh yeah, I forgot. My bad, I taught my other class. All right, so here's the deal. Instead, didn't you learn at the school to do group and garbage? Okay, so let me just show you group and garbage. If we were to do it, it would look like this. I'm going to show you that this is much easier. So if you were to do group and garbage, wouldn't you take these and they would become your two middle terms, right? And then wouldn't you have to group the first two and group the second two? Mrs. Baker calls them twosies. Puts a slash there, right? Take out the GCF from the first group here. Wouldn't it be 3x? Take out the GCF from the second group here, and it's a negative because we want that to be positive. So it's a negative 2. Notice how what's in the parentheses is the same. So that gets factored out in front. And then don't we have a 3x minus 2 that gets put into the next parentheses? And then don't forget, of course, the x minus 2 that we started with. So that's all that group and garbage. I propose a much simpler method. Are you ready? Ready? Okay. So we still do the t-chart or the x. Mrs. Nelson does the x, right? However, you have to do your factor sum. So we still went through this, but you take your bookends, put them on this diagonal in a 2x2 box. Just trust me. You'll like it. And then you put your middle terms, remembering to put in your x, on the other diagonal. This diagonal with your middle terms is what determines the sign. Didn't we have to determine the signs here ourselves? So the signs in these are important. So we're going to find greatest common factor, but I don't care about signs because I already know, since this one's negative, my sign up here for this term is going to be negative. This one's negative, I'm going to get a negative sign over here. See what I mean? We're going to find our GCF going up first. So in this column, what's the GCF between 6x squared and 3x? What does 6 and 3 have in common? A 3. And how many x's? 1x. So I've got a 3x as a GCF for this column. What's the GCF between 4 and 2? I don't care that it's negative. 4 and 2. 2. No x's in common, right? So we have a 2 here. But because this box is negative, we're going to put a minus 2 there. You just found your first binomial without group and garbage, 3x minus 2. Then you're going to find your GCF going to the left. So you're going to go rows out this way. What is your GCF between 4 and 6? 2, and then they have an x in common, so a 2x. What is your GCF between 3 and 2? Nothing, right? A 1. When they have a 1, everything has a 1 in common, doesn't it? And they have no x's in common, so we have a 1 in common. But this box is a negative, so it's a negative 1. So our binomials are really here 3x minus 2, and here 2x minus 1. No need to group and garbage. And then don't forget to bring down your x minus 2. I'll do it again, so you can see it again. But the math is a whole lot easier if you use the box method. You could. Takes you longer, and there's more room for error. I know, you always like what you started with. Be open-minded. All right, so then, yes. Right here? So all I'm doing is taking your greatest common factor up. Oh, this right here? No matter whether you use this box method or group and garbage, you always have to take your bookends, your first coefficient and your last constant. You always have to multiply those together. Oftentimes in this class we've had a 1 there, right? So all you've ever had to factor for quite some time is the constant. But the minute you have a constant in front of the x squared, you have to do 6 times 2. So it's a product of 12. That product is positive, so you're adding the factors of 12 to get your middle term. Does that make sense? All right, so let's look at the next one. So then example 2, this is a different way to ask you to divide, isn't it? And you should have learned how to factor cubes, difference of 2 cubes in Algebra 3-4, but that's not what we're going to do here. We're going to do long division. Am I missing any x terms in the numerator? Yes, what am I missing? X squared and an x. So underneath my division bar, I'm going to start with my x cubed, and sometimes you need your placeholder, sometimes you don't. It just depends. I'm still going to put them in, plus a 0x squared because it has no value, and then plus a 0x, and then your constant minus 1. If you forget which one goes underneath the division bar, think of this as a 1-car garage. The top car gets parked in there first, the second car gets parked outside. And so then we're going to do long division just like we did before. Focus on your first terms. Take x cubed and divide it by x. What do you get? X squared. Multiply it all the way through here. X squared times x. X cubed. And then x squared times negative 1. Negative x squared. If I didn't have my placeholder there, there would have been a negative 1 there. They would not be like terms and they would not line up. Don't forget to draw your line and change your signs. So your first terms cancel out and then add down. What's a 0 and a 1? So just an x squared. Then bring down your next term. So I have a plus 0x, and the whole process starts all over again. So then I've got x squared divided by x. So an x, positive x, multiply all the way through, x times x, x squared, x times negative 1, negative x. Draw your line, change your signs. The first terms cancel, and I have a 0 plus an x. Doesn't that give me an x? Bring your final term down, minus 1. Starts all over again. So I'm going to focus on my first terms. What is x divided by x? 1. That's a positive 1, so plus 1. Multiply that 1 all the way through. 1 times x is x, and 1 times negative 1 is negative 1. Draw your line and change your signs. Everything cancels out. You get a 0 as a remainder. So since that 0 is a remainder, isn't this a factor of this? Now, they did not say to use the division to factor, they just said to divide. So isn't our answer to the division problem x squared plus x plus 1? Isn't that my answer? So note the difference in the directions. One asked you to use the long division to factor with. The other one said, no, just divide. Question?
So when you're dividing, you put in front of the 0 x squared, you don't count the 0 as a 0, you don't count the 0, so just so that it doesn't
It has a value of 0. Is that what you're asking?
Well, because we divided the x into 0 x squared instead of keeping the x into 0.
I didn't divide it into 0x squared. I multiplied. I never divided here. The only time I used the 0x squared was to add down. I never divided by this. I only divide the first ones. Does that make sense? Okay. Any other questions on that? Okay. So, look at this one. Is it asking you to divide and then factor, or just to divide? Just to divide. So go ahead and try that one on your own. You will get a remainder, and we're going to talk about what you do with your remainder. So while you're doing it, I'll do it up here silently to myself, and you can watch as you go. Do your thing. Look for placeholders. Do you need any placeholders? Nope. I will interject here. It is a long divisor, so you do have to bring down 2 additional terms in order to match the fact that you have 3 terms out here. So how do you feel? When I multiplied the 2x squared through, the 2x squared times a negative 3 is a negative 6x squared. And then I ended up changing my sign when I drew my line.
Oh, okay,
Is
so
it-
multiply the 2x squared times
to
2x
everything.
and then negative 3.
It has to get multiplied all the way through.
And then you don't bring negative 5x squared down.
Well, no, because it's underneath here, so I can't bring it down because it's being
Oh.
used.
Okay.
Does that make sense?
Yeah.
It's being used in the sense that I do combine it with a positive 6x squared to get a positive x squared. But I do bring these 2 down because I need 3 terms here to match 3 terms here. Because if I don't bring both of them down, then this one's missing something. There's nothing above it. Okay? So how else, anything else that we had issues with? So we do have a remainder, don't we? So that tells me that x squared plus 2x minus 3 is not a factor of what we divided into. However, this is how we're going to write our answer. We only have 2 terms in our answer, 2x squared and a plus 1, right? So we're going to take over here to the right that 2x squared plus 1. And then anytime we have a polynomial remainder, you will always add the remainder. Okay, anytime you have a polynomial remainder. So we're going to add whatever a remainder is, in this case x plus 1, you always divide it by what you divided by. So we're going to divide it by this entire quadratic here. X squared plus 2x minus 3. This is my entire answer. So you take your remainder, always add it, and put it over what you divided by. Done. So before we flip it, let me just say that if we did have a remainder here and we had a number remainder, like any kind of integer, then you would add or subtract that remainder here by what you divided by. So if it were a positive number, you'd add the remainder. If it were a negative number, you would subtract the remainder. And you would always put it over whatever you divided by. So if I had a plus 5 down here, I would add a 5 over x minus 1. If I had a minus 5 here, I would put a minus 5 over x minus 1. All right, so let's look at the back. So let's do synthetic division. Synthetic division is a shorthand form of long division. And the only time you'll see me using synthetic division is if I have a binomial here and there's a coefficient of 1 in front of the x. If there's not a coefficient of 1, you're going to run across that in your homework, and we'll talk about, I want you to think about what would you have to do to get rid of that coefficient in front of the x. But we're not going to discuss that today, so I want you to think about it in your homework. So all you're going to do with synthetic division is ignore all of your variables. Am I missing any x terms? No, I have a cubed, a squared, a first, and a constant. So if I am missing it, I still have to put in a 0 as a placeholder. But I'm going to drop all the x's and just put in the numbers. So I've got a 6, a negative 19, a 16, and a negative 4. And I'm going to drop a big L. Behind my last number, I always draw a vertical line, and I'm going to put a shelf over here. You did learn this last year. Now, what to put on the shelf? What do you think I put over here? What am I dividing by? X minus 2. But remember, this, if I were to, I'm trying to find my zeros, right? So if x minus 2 is a factor and I set it equal to 0, what would x actually be? 2. So inside parentheses, don't I usually do the opposite sign? So I'm going to put a 2 on my shelf because that's what I'm dividing by. I'm not dividing by a negative 2. I'm really dividing by a positive 2 because that's the 0 I'm checking for. If x minus 2 is a factor, that means it's also a 0. Set it equal to 0 and solve for x, you're going to have 2. All right, so here's how, just to remind you how long or synthetic division works. Don't we bring down the first number? So I'm going to bring down the 6. And then what do? Multiply. So what's 2 times 6? 12. Pay attention to your signs. Then add down. What's negative 19 and 12? Negative 7. So multiply again to the 2. What's 2 times negative 7? Negative 14. Add down, what do you get? Positive 2. And then multiply again. 2 times 2? 2 times 2? 4. Add down, and you do indeed get 0. What does 0 tell you about the fact that x minus 2? That means that x minus 2 truly is a 0, because it is a factor. If you have no remainder, then that means you have a factor. So, no remainder means 2 is a 0. And aren't zeros where the graph crosses the x-axis? Okay, so I found a 0. But they really want us to use synthetic division to divide. So when you use polynomial long division on the front, what did you notice about, I started off with an x cubed, and I ended up with an x squared. I started off with an x cubed, I ended up with an x squared. So what happens to your first term? You have 1 degree lower, right? So if I want to figure out what my variables are that are attached to these numbers, if I started off with an x cubed, isn't this an x squared, and isn't this an x, and wouldn't that be my constant? So my final answer would be 6x squared minus 7x plus 2, no remainder. If there was a remainder, whatever the sign is of the remainder, so if it's a positive remainder, we would add that number divided by x minus 2. If it were a negative, we would subtract that number divided by x minus 2. Okay, so done with that one. Then look at example 5. Again, we're using it to divide. Is there anything that you see that's wrong? Okay, so we're missing an x squared, so we do have to put in a placeholder. So what's our coefficient in front of the x to the 4th? So we're going to put in a 1, negative 10. I'm missing right here my x squared, so it's really a 0. And then a negative 2, and then a positive 4. Draw your L, draw your vertical line, and your shelf. Now I know some of you do an even shorthand of synthetic division, especially when we do repetitive synthetic division. You won't see me doing that. I'm more about showing work. You can do it if you remember it and like to. So what am I going to put on the shelf? A negative 3, because it's the opposite of what's there, right? And then what's the first step? Bring down that 1. And then multiply. So negative 3 times 1, negative 3, add down, negative 13. Negative 3 times negative 13 is what? Positive 39, right? Add down. Negative 3 times 39. Add down, what do you get? Negative 119. And then negative 3 times negative 119 is a positive, right? And you get a positive 357, right? Add down, what do you get? 361. So is x plus 3 a factor of the polynomial? No. But we're just using it to divide, so this is our remainder, and our remainder is positive, isn't it? So here's what you're going to do with your remainder. We're going to add our variables onto this. What's this one? X cubed. So this is x squared, and this is x, and this is our constant. So our answer is x cubed minus 13x squared plus 39x minus 119, and then plus the remainder because it's positive of 361 over, we divided by x plus 3. All of that's a review, correct? I haven't given you anything new yet today. All right, so have you heard of the remainder theorem? Talk about that in pre-4 at all? Okay. Remainder theorem is actually kind of awesome in one respect. All it says is that if a polynomial function is divided by some binomial, the remainder is f of k. Well, that doesn't mean a whole lot to you. For instance, see how we got a remainder here? 361. And we divided by negative 3. Take your calculator and input into y equals that polynomial function. So x to the 4th minus 10 x cubed minus 2x plus 4. So there's my graph. My guess is I'm not seeing the entire graph. Why is my guess I'm not seeing the entire graph? What's the highest degree term? X to the 4th. What's the end behavior supposed to be? Both tails are supposed to be doing what? Up. Are both tails up? I'm guessing there's something down here that we're missing, right? We could zoom in, but is that our goal right now? You don't know what my goal is, do you? So let me ask you this. What if I asked you to evaluate this function for negative 3? Wouldn't you normally have to put negative 3 in to x to the 4th and raise it to the 4th power, then raise it to the 3rd, and finally multiply it to the negative 10, then multiply it to negative 2, and then finally you'd add all those values together? Is that kind of a pain to do by hand? But I can do it on my calculator, can't I? Go to your table function and please input negative 3. Mine's already input down here. What do you notice about the y value? 361, is that familiar? Oh look, it's the remainder. That's your remainder theorem. That's what it's saying is whatever this remainder is, if I evaluate the function for -3, whatever I divided by, this remainder is the value of that function at -3. Just like if I'd gotten a 0 here, our 0 would have been, oh, the value of y would be 0. That's why we end up with a 0. We know that when we end up with a 0, it's a 0 for the graph. Because that's actually, our synthetic division is actually evaluating the function at that point. So, use the remainder theorem to evaluate the function at x equals -2. So we really want to find f of -2. So instead of plugging it in, if I actually did f of -2, I would actually be plugging it in I'll be plugging it into here. So we're going to do it the long way first, and then we'll use synthetic division. So don't I have to raise -2 to the third power first? What does that give me? -8. And then -2 raised to the second power, +4. So then multiply, we get -24, +32, -10, and then finally -7. If I add all my negatives, what's -24 and -10? -34 minus 7, -41 plus 32. What does that give me? -9, right? So that means that f of -2 is equal to -9. Okay, let's see what happens in long division, or synthetic division. This time they didn't give me x plus 2, right? They just said x equals -2. So this is what I put on my shelf, because it's solved for x. So I'm going to take and remove all of my coefficients. Am I missing any x's? Nope. So I've got a 3, an 8, a 5, and a -7. So draw your L, vertical line, and your shelf. Put in your -2. Drop down your 3. And multiply. So -2 times 3 is -6. Add down, we get 2. -2 times 2 is -4. Add down, we get a 1. -2 times 1 is -2. Add down, what do we get? -9. So again, f of -2 is equal to -9. Which would you rather do? I'd rather do the synthetic. It tends to be easier. Okay, so that's all the remainder theorem says. So you need to understand that if I'm asking you to use the remainder theorem, what I'm asking you to do. So that's a study tool for you. All right, then one last part. So flip it. We're going to use the factor theorem. A polynomial has a factor, it's a binomial, if and only if the synthetic division is going to give you a remainder of 0. Didn't we just talk about that? Right? So that's all the factor theorem says, is that your remainder is 0. And we've been discussing that all along. So I want you to show that x minus 2 and x plus 3 are factors of the polynomial, then find the remaining factors. So we're going to use repetitive synthetic division. So our very first step, just choose one of the two. Which one do you want to divide by first? Okay, so it doesn't matter, does it? So I'm going to start with that one. Am I missing any x terms? No. So go ahead and do your synthetic division. Making sure that on your shelf you're putting a +2, not a -2, because we're changing the sign. So if they're telling you that they are factors, you darn well better be getting a 0 for your remainder. If you don't, you did something wrong. So now if I want to plug in x plus 3 and divide it into here, I'm just going to use these numbers. So my second step is to continue, because I'm trying to actually factor this. So I don't want to refactor this again, because I'm trying to factor this into smaller and smaller pieces. So really what I have here is 2x to the third, 11x squared, 18x, and then a plus 9. So I'm now going to factor that. You could continue from here if you want to, I just choose not to. So what am I putting on my shelf? Negative 3, right? And then do your synthetic division. So again, you should be left with 0. So if we started here with x to the 4th, what is this? X cubed, so what is this? X squared, and this is x, right? So right now what we have for our third step, because we are trying to fully factor, we started off with an x minus 2 and an x plus 3, and our final, after synthetic division, is 2x squared plus 5x plus 3. So we got to factor that. So I'm going to go through the box method with you again. We've got a coefficient in front. So 2 times 3 is a product of a positive 6. That means I'm adding the factors of 6. I'm looking for a middle term of positive 5. What factors of 6 add to give you 5? 2 and 3. You have to be really careful with factors of 6. I'm looking for a positive 5. The bigger of the two always carries the sign. What's the 2 have to be? It has to be positive in order to combine and make a positive 5. So my middle terms are x's, so that's a 2x and a 3x. So in your box, your bookends, the 2x squared and the 3, go in this diagonal. And then your middle terms that you just found, the 2x and the 3x, they go in the other diagonal in whatever order, it doesn't matter. These ones carry the sign. So I know I'm going to have all positives. It doesn't matter what these are. These should always be positive. Well, this one might be negative, but it doesn't matter. Whatever this sign is and this sign will end up being the signs of my binomials. So I'm going to find my GCF going up. What's the GCF between 2x squared and 3x squared, or 3x? Just an x, right? And then my GCF here? 1, because there's nothing. And this is a positive, isn't it? Bless you. So I have a positive 1 here. So there's one of my binomials, x plus 1. And then I'm going to find my GCF going to the left, between 2x squared and 2x. 2x, between 3x and 3. 3. And this is positive, so I know it is a positive 3. So these are my two binomials. So I finish it out. Step 4, well, I guess it's still step 3. X minus 2, x plus 3, and then my two binomials I just came up with, x plus 1 and 2x plus 3. The math is oodles easier using that box. It's quicker than grouping garbage also. As long as you remember your signs, you get them correct. All right, so that's it for today.